Chapter 11, Gases, Section 11.1, Properties of Gases. No video problems that goes along with this. So what are just some general physical properties of gases? We're usually talking about molecules that have fewer than 5 atoms. And the reason why is because as we increase the number of atoms, of course we increase the number of electrons. As we increase the number of electrons, it becomes more and more polarizable, which means that it has stronger London dispersion forces. And the stronger the London dispersion forces, the more likely it's going to be a liquid or a solid. So fewer than 5 atoms typically, usually the first or second period. And again, we're looking at number of electrons. Okay, fewer number of electrons, the more likely it is to be a gas. So they're always spread far apart. They have no definite shape or volume. Used to that from middle school. They will completely fill any container. So if I have a gas in this container that's sealed, and then I pump it into a gas that's this container and sealed, the gas, let's say this is 1 liter, let's say this is 5 liters. The gas starts out occupying 1 liter of space. It ends occupying 5 liters of space. So it'll always fill the container, luckily. They're typically less dense than a solid or a liquid, and they are very compressible. Right? So how does the kinetic molecular theory describe the behavior of a gas? Remember, it's a theory, so it explains how or why something occurs. And these are just the 5 ideas of the kinetic molecular theory in terms of a gas. So a gas consists of small particles that move randomly with high velocities. The attractive forces between the particles of a gas are very small. We often say that the attractive forces are 0, they are negligible, which this is what's called a false assumption of the kinetic and molecular theory. Because it's something that's actually, we do have, between these gas particles, we do have a force of attraction. No matter how far apart they are, there is a force of attraction there, but it is relatively small. Okay. Another false assumption is that the actual volume occupied by gas molecules is small compared to the volume that the gas occupies. So what we say typically is that the amount of space they take up is negligible. And so why that's important is because here, let's go back to this 5 liter container. Here's this 5 liter container. Let's say these particles are right in there. Right? So we say that the gas occupies 5 liters, but it doesn't really, because the particles themselves occupy space, which removes space from the 5 liters. Right? So what I often say is, imagine that we're looking down on a classroom, and here's a desk, 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 and here's a desk. And I ask you to figure out the volume of this classroom, right? So if I asked you to figure out the volume of this classroom, you would probably just take length times width times height of the classroom. But that's not the actual volume of air in the classroom. If I wanted to figure out the volume of air, I would have to subtract out the volume of the desk, right? So what we're saying here is, when it's in 5 liters, we just assume that the gas particles don't take up any space. And so we don't subtract out that space. In the ideal gas law, there is a different gas law that that space that it takes up is subtracted out, but we're not worried about that right now. Okay? We say the gas particles are in constant motion, constantly moving in straight lines, and the big important one, the average kinetic energy of gas molecules is proportional to the Kelvin temperature. So the temperature in Kelvin is proportional to the average kinetic energy. Very important. Okay? As you increase temperature, you increase the kinetic energy. So there are 4 properties that we typically use to describe a gas. The pressure, oops, going for a highlighter there. The pressure, and pressure is created when the molecules hit the side of the container, and that's important to know and important to remember. Right? More heat makes the molecules move faster, which creates greater pressure because they're hitting the sides of the container more often and with increased force. Okay, so both those things, not just more often, also increased force. Because when you increase the temperature, you increase the kinetic energy. Gas particles in the air exert what's called atmospheric pressure. So here's some Malfoy, right? He has all sorts of gas particles on top of him. Well, those gas particles are all exerting force, right? So they all exert force on your head, which is atmospheric pressure. Some units that can be used to describe this, atmospheres, millimeters of mercury, which is literally, so if I have, here's a tube, right? And that tube is full of mercury. So the atmosphere is literally, you know, how many millimeters of mercury would exert the same amount of force. That's what it is. And then kilopascals, kPa, right? The volume of a gas, it always fills the container. So if you put more particles in an expandable container, that means they have greater volume. A decrease in temperature slows down the molecules. That reduces the force against the side of the container. Now, that means if we have an expandable container, that container will shrink. So think about a balloon. A balloon is an expandable container. Okay, if I blow more air into that balloon's going to get bigger, more volume. If I take this balloon outside on a very cold winter day, like in the negatives, this is going to drop. Okay, the size of that balloon is going to get smaller because molecules are moving slower, not colliding against the side of the container with as much force, which means they have a decreased volume. Temperature is a biggie. Okay, it's related to the kinetic energy. It's the average kinetic energy. And then you can read some of those other ones yourself. And then the amount of gas is how we often describe it as well. The amount of gas in, which is moles. Okay. Now, very important up here, let's talk about temperature again real quick. Temperature is measured in Kelvin. Okay, so long as it's a capital T, it's Kelvin. Now, there are some times where you can use Celsius, but generally with gases, you always want to use Kelvin. The reason why is because it's tied to the kinetic energy of the gas.